Okay, so hello everyone. Welcome to my talk. Today we will go through the audit. I will reveal some of our auditing techniques that we are using and what we did to help to secure the CSM. So my name is Jan. I'm tech lead at Ackee Blockchain, and we are doing mostly blockchain security audits, but we are also, apart from that, developing some open source tools and teaching at Czech Technical University at Prague, and for example, also doing some online courses and so on. We are in the space more than 3 years, and we work with clients such as 1inch, Safe, Axelar, and now Lido. So the scope is pretty clear. I think I don't have to explain what is CSM. The other part of the scope was some of the updated contracts from the core repository, and now what it means for the auditor, the scope. So first of all, it's permissionless, and when something is permissionless, it's usually more fun to exploit it. It's if you have a strict code base where are always only owner modifiers, and you find critical there, then it's protected by the multisig, and it's not critical at all. So permissionless code base is always more fun. What is more important is that it's connected to some existing architecture where it can possibly bring some new entropy, create some new attack vectors. So that's also a very interesting point. And then there are bunkers and possibly a lot of fees, so a lot of motivation to break it and much more. So we have a scope, so we can dive in. First, a discipline or the important part of the audit is manual review. Most of the auditors find most of the issues with the manual review. But the second important thing to make the review good is to do fuzzing. Can I just ask who knows what is fuzzing? If you can raise a hand. Cool. So I will just quickly explain. It's basically some sort of testing where you are putting random data to functions and executing them many times. We will get more to that topic later. So this is just a high level. And then the third discipline is tool-based analysis, where if you are doing everything manually, that it can be possibly slow. So tooling can help you to be more effective. So if we put these three disciplines together, we get a powerful stack, where from this stack, we will just get through a lot of points, which I find out important to say that helped us to accomplish the review with good confidence. So the first thing was that we split the scope to 2 teams, and this helped us to have a quicker delivery. So we had 2 teams working in parallel. We were doing regular meetings, things between each other, and thanks to that, there was a quicker delivery. One of the very great good decisions from the beginning was that we started very early with fast tests, because since you are working with some random input, you are working with some probability that if you run these tests longer, then you have a greater chance that you will discover something. So the ideal scenario is that you will be able to create these tests in the first half of the audit, and then continue on a review, update these tests, and run them for the rest of the audit. So they have to be run along. So there is just a picture of a commit, what we had that Michal, my colleague, just had some faster setup already on the day 2 of the audit. Then, now more about the fuzzing. What we are doing is something what we call manually guided fuzzing, which is consisted of flows and invariants. It is very similar to fuzzing in Foundry, and a little bit different from the fuzzing in Echidna. So flows are basically some scenarios with which you are instructing the fuzzing engine what to do, the fuzzing campaign. So Usually there are, for each flow, there is one corresponding function. And let's say we are transferring tokens. So we are writing fastest for ERC20. Then we will create a flow for transfer. And it will be about that it takes random amount A, random account X, random account Y, and just do a transfer. And this will be done like for 1,000 times, millions. And we want to check if these values were transferred correctly. So this is where comes invariance. So these invariants can be stateful or stateless, where if we will be doing the stateless ones, it will mean that on this example where we have a counter and we are doing decrementation, then stateless invariant will be something like a basic assertion, where we just get a value before the decrementation and compare it after the operation if it matches the expected value. So this is just in the context of the one flow, but we want to have the context like a more wide. And this is where comes the stateful testing with the global invariants. This is extremely handy when you have like tens of flows, tens of invariants, because in that case, you are able, like, after each flow, check for all the invariants. And when you want to implement these stateful invariants, you need to create some state for it. And that's where comes to the place the differential testing. So we essentially created a Python model of Lido. So we rewrite Lido to Python, and then tested it against the Solidity contracts. So the Python model was created based on some specifications and expectations how the protocol should behave. And there's example of node operator class, which contains a lot of parameters, and all of these parameters are then checked. So this is example how some of these flows can look like. So first we generate some random values. Then there is a lot of code branching based on the functions. And in the end, we are assigning the values for the new node operator. And this is just part of the invariant for checking the node operators. So what it's essentially doing, it just checks if the state of the Solidity is same as the state in the Python. Cool. So why is this useful? It can help you discover very unique issues where we don't need to dive into this one, but enough will be to just read the first sentence, where if you would like to find this manually, then there is a chance that you will miss it, or it will take you like a lot of time. In case of defuzzing, you can get the resulting scenario like in a moment. So try to search like manually for the combination which will break it, which is like 5 deposited keys, 2 keys waiting to be processed, 6 vetted, and 1 unbonded. So if you will find this manually, it's great, but with fuzzing, it's easier. And you are still working with some time budget what you have for the audit, so you are trying to be most effective. Then we have their forking, which is very powerful thing. We had, for example, like in the staking router part, we had just a few contracts updated, and the rest of them were out of scope, but we have to use them for our test. And we could like deploy them manually, or create some simplified versions of them, or we can fork them. And this like gives us like more real scenarios for the testing, and it's like thanks to that, it's very quick implementation. For example, Lido locator, we will just fork it into our tests, and we have all addresses of the contracts on the mainnet. And if we want just pass our locally deployed address, we will just upgrade it and pass the new address to it. Okay, and another interesting type of fuzzing is fuzzing over deployment. So this is after the end of the audit. We just took the new addresses which were on the mainnet of the contracts what we were previously auditing, and replaced the simple local deployment with the forking. So basically at that moment we were forking everything, but still fuzzing. So we were fuzzing contracts on the mainnet, which is pretty cool. Another thing that helped us to verify that everything after deploy is behaving as it is was the verification of deployment, where there is forking also utilized, where there's example of verification for CS accounting contract. So we just deploy it with the same parameters locally, check the code, and compare it with the code from the mainnet. Another useful thing during audits is to have strong static analysis and to use Leica detectors that are not just about that there is some unused error or something like that, but that can lead you to something what could be potentially more critical. Where one of them is a detector for missing returns, where you just go through the code and see there is something underlined. You will check it, and you will get a message that not all execution paths have assigned return values. So it means that the function returns some value, and in some branch of the code of the function, there is no return at all. So in this particular case, there was no return, so it was always returning the default value, which is false. And that means that even there was a successful operation, it returned false. In this specific example, it does not lead to some more severe issue, but you can imagine that, for example, if you have some deposit function that returns Boolean value about success, and then there are some funds that were not transferred, and it returns true, or quite the opposite, that it can break some logic in other contract. So an interesting fact on this is this issue was there from February 2023. So that's also the thing that static analysis can search for some patterns in the code that are from some weird reason invisible for human eyes. And this one is very interesting. We are a lot of working with information bias, where, for example, when I was talking about early fuzzing, it's some sort of a blindly testing where we just went very quickly through the documentation, what is the project about. And without any knowledge, we just started deploying that and trying to do some things. This can seem weird, but it is extremely helpful because if you are selecting some information about from the documentation, for example, first you go just through the high-level documentation, then you will go through some diagrams, then you will, for example, look into test folder, and you are receiving the informations more slowly during the audit, and this can give you more creativity during the audit. Because if you will learn everything at the start of the audit, for example, look at the worst thing what I think you could do, that you will check deployment parameters, like the constructor arguments, how the contracts have to be deployed, then you will lose all chances to pass them any interesting values. So, and another important thing is to visit the documentation in different audit phases. Sometimes you will read it, you will miss something from the documentation, then you will get back to it later. And also in the end of the audit, you will get back to it if everything is as you understand it. Okay, then we have there a lot of code navigation techniques, which is from the tool-based part. And this is example of a graph, control flow graphs, what we are using, where this particular one is about adding a new guardian, where we can easily see that the only branch that leads to success in a case where the new guardian is not a zero address, and if isGuardian function is returning false, then it will perform these three operations in the block on the right. Then another extremely useful feature is that you have some printers in LSP, for example, for public functions. So then you can nicely go through the full public and external entry points in the inheritance chain of the contract. So it can seem like a trivial, but it is extremely helpful because a lot of times developers forgetting some open entry points in the inheritance chain. So in this example, we can see that Accounting Oracle has two base contracts, where base Oracle has 4 opened functions, and there is also another access control contract that has 3 functions. And then there are a lot of others, navigation techniques like references. You can check if this interface, in which parts of the code base is referenced, and other features that helps to fasten the audit process. Okay, this one is probably the most useful feature. For example, when we used to, let's say 1 year ago, when we were running fast tests, we run them overnight, and then we wake up, came to it, and we had just a revert message that it failed. And we have to search for the issue, why it failed, and then we have to run it multiple times again to know if it was fixed, and we can't be actually pretty sure if it is fixed because it's always random. So this is where comes seeds, where after each fast test fails, it prints the seed, and we can reproduce the same fuzzing sequence. So we can be sure that the error which failed in the specific fuzzing sequence is fixed after our fix if we reproduce it with the same seed. And another important thing is that we can now attach debugger to these fuzz tests. So if it fails, then we can nicely go through it, which can be seen on this example. So there is turn on fuzz test, which is running. Then there is attach debugger. We can see the error message and basic a traceback, and we can check some state variables, for example, account balances and so on. We can access the transaction that failed, check its error message, its call trace, and try to debug our problem. And after that, we will rerun it with the same seed, and if it will not fail this time, so it's fixed, and we can just again start with another seed. Okay, and last but not least, important thing is just the communication. Here I have to verify a Lido team because they were always very responsive. So this also helps during the audits a lot, because if you don't know something, it's important just to ask. If it's something suspicious, again, ask. You can for example, debug some things together, and it's very helpful. And also, I have there one bonus thing, which we just started with this audit because there was a lot of us. We were doing collaborative sessions where during the audit there were only virtual one, but last day of the audit we just make a session in the office, and in 8 hours we ordered pizzas, white monsters, and were grinding and trying to go line by line through all the contracts and just find if there is something what we missed. But unfortunately, we didn't find anything this day, but it definitely gave us a better confidence. So the results, if you ask, we had 46 issues, where 32 of them were fixed. Where what is interesting, there was 6 findings which were discovered by a long-running fuzz test. So usually, when you are writing fuzz test and also doing manual review, you find it bugs like with the manual review, or when you run the fuzz test, then you will find it like in 10 seconds that there is some issue. But if you find that issue like after 1 hour running fuzz test, then it means that you've written that fuzz test like correctly, because that's the way how these like unique findings should be found. And there was no critical NI, I should have to say. Yeah. So if you're asking what is the tool what we were using, it's called Wake. It's testing framework. It has also its own static analysis framework, and it has a language server that enables use of the VS Code extension, which was the extension where that was that screenshots in the presentation. And for those who like already knows this tool, then I have good news that we are rewriting the framework to Rust. And currently we measured our tests on Lido, what we've written, and we have approximately 10x speed up. And on some tasks, it's also like even more. So soon there will be like a new friendship. And that's it. That's it all. Thank you.
Thank you, thank you. That was amazing. Any questions? I'm just wondering, maybe technical guys. You asked during the audit, I guess. Yeah, sure.
Yeah, thank you a lot for overview. Interesting that you're auditing with pizza and we call it with coffee. Yeah, so the same. My question about, will it help if Lido will provide the fuzzing test along the code? Will it help or not?
Yeah, that's the thing what I was telling about the information bias. Like I'm usually not using tests of the developer team, so I think like if it will be written in something what is like well recognizable, for example, in Wake, then we could use it at the like as a last step where we will check what you have actually covered, because we can, for example, generate coverage for that, and we will focus on the things that are not covered, or it can like give us some information about how you like tested it, and we can like retrieve from that what we should focus on based on that. But mostly we are not using like tests of the developer teams.
Yeah, okay, so you still write own and the price was not changed, okay.
About prices, I guess.
Yeah, and the last my question is about formal verification. Do you have a plan?
Definitely not. Like we had like a lot of session. Like I don't want to say that those are like clashes. It's in a friendly way, but there is like a common like dispute. What is better, if fuzzing or formal verification? Like from my point of view, the differential fuzz testing becomes like very similar to the formal verification, because you are also creating some sort of a model which you are testing over. But yeah, no, we wouldn't do that.